Optical Microscopy versus Electron Microscopy by Michael Thomas. Optical microscopy is obsolete now that electron microscopy is readily available. This will dive into what each of them are and what they bring to the table. There are two main types of optical microscopes, simple and compound. Light microscopes are much older when compared to electron microscopes. The optical microscope is often assigned another name, the light microscope. The first compound microscope was invented in the late 16th century by Zacchaeus Janssen and his father Hans. Simple microscopes have a single lens to magnify the object. Meanwhile, compound microscopes have 3 to 5 lenses to magnify the object. Any object that is less than half the wavelength of the microscope's illumination source is not visible under that microscope. Light microscopes use visible light, which has a minimum wavelength of 400 newton-meters or less than 1,000th of a millimeter. This means that we will never be able to see any object smaller than approximately 200 newton-meters, about the width of an average sized brachiomium, using light microscopes. In the same way that light has a wavelength, the movement of high-speed electrons also has a wavelength. The wavelength of electrons is thousands of times shorter than visible light, so scientists predicted that electron microscopes would be able to resolve objects that are thousands of times smaller. They were right. The way an optical microscope works is a beam of light comes from below the object, goes through a very thin, transparent condenser lens, then reflects through the specimen, through an objective lens, refracts again, then through an eyepiece lens, and finally into the focus of your eye. The beam of light is focused using very thin glass lenses, but it relies on the beam of light being capable to pass through the object, which means that the object must be extremely thin and transparent. To figure out the magnification of the microscope, you would look at the magnification of the eyepiece lens, then multiply that by the magnification of the objective lens. Some advantages of the optical microscope are that they are easy to use, they are relatively cheap. Most school microscopes are around the $200 mark. They show true color, but may require staining. Another big advantage is that the specimen that is looked at can be alive. It doesn't have to be killed to be studied. Some disadvantages are that the resolution is only about 0.2 of a micrometer, which sounds like a lot, but when talking about the microscope, it really isn't. Another downside is the magnification is only about 400 times magnification. The problem with the microscope is that the specimen must be very thin to fit on the sides. As a result, the specimens may not be represented what the cell looks like in its entirety. There are also two main types of electron microscopes, transmission electron microscopes and scanning electron microscopes. These microscopes are much newer and can achieve much greater things than optical microscopes. The first electromatic lens was developed in 1926 by Hans Busch. It is a microscope that utilizes a ray of accelerated electrons as a source of illumination. Electron microscopes have a greater resolving power than light microscopes and can expose the structures of smaller objects. This is due to the wavelengths being able to become up to 100,000 times shorter than that of visible light photons. The reason why the SEM and TEM have black and white images are because electrons don't correspond to wavelengths of light and colors. Colors have to be added digitally. This is based on how many electrons are absorbed. Instead of light, electrons and their wavelengths are used which are shorter, which results in higher resolution of the image. Specimens are not directly observed. You do not look through an eyepiece. A computer forms an image based on how many electrons are absorbed by different regions of the specimen. Then the computer can make an image for us to look at. The way the microscope works is an electron gun at the top facing down to an anode to focus the beam of electrons, then several focusing magnets, then scanning coils and electron detectors which generate an image, then to the bottom of the stage, which then reflects the electrons back from the object. The way that it works is it directs a ray of electrons at the object, then creates an image based on the electrons that are reflected off the surface of the object. To focus the image, electromagnets are used. The advantages of the SEM microscope are that the resolution is much higher than an optical microscope, to be exact 1 nanometer. These microscopes can create extremely detailed images of surface structures of the object being examined. They also have a much higher magnification rating. It can go up to 200,000 times. An amazing feature with the SEM is that it can create 3D images. Big disadvantage of this microscope is the price of it. The sample of the specimen that would be desired to study would have to be dead. This is because the electrons have to pass through a vacuum, as well as that the stains that are used can contain heavy metals which can be toxic. Another downside is that it produces a black and white image, or true or a false color image, which means we cannot get a full representation of what the true color of the specimen may be. Optical microscopy is obsolete now that electron microscopy is readily available. This is because it has made the optical microscope outdated and is much more precise and accurate. This is because the resolutions are much greater than optical microscopes. The magnification difference from each of the two are outstanding. The fact that the SEM creates an image that is 3D is very pleasing as well. It also provides detailed images of interior structures of cell organelles. This is proof that optical microscopy is obsolete now that electron microscopy is readily available.